Welcome to this deep dive into AWS instance metadata. My name is Ignacio Dominguez. I'm a cloud security engineer at Holborn and also a co-founder of HackerTraining, where we have created the AWS Red Team Expert certification. In my spare time, I also do CTF development for conferences such as NahamCon. Today, we're going to be looking into what an IMDS is, what information is available, how attackers can exploit IMDS, differences between version 1 and version 2, how attacks against version 2 are different. We're also going to be looking into other AWS services such as ECS, CodeBuild, EKS. So IMDS is the instance metadata service, and it's a component inside EC2 instances that allows us to get information about that instance. It is available through the 169.254.169.254 IP address, and it is only accessible internally by the EC2 instances. The information that we can obtain here, the most relevant is the IAM role credentials. This allows us to use the role that the instance has been configured to use. This is very helpful to escalate privileges or obtain access to the AWS account. We also have access to user data. This is a script that runs on the instance startup, the first startup, and very often it has hard-coded credentials inside of it, so it's always good to check. And other than that, there are some other details that can help identify the resource that is affected by a vulnerability. So it's really helpful for reporting to be able to enumerate things like the instance ID and the region to be able to tell the triager exactly where you found the issue. In order to attack IMDS, the most popular attack is a server-side request forgery. This is an attack in which the attacker is able to trick an application running in a server, in this case an EC2 instance, to make a request to the instance metadata endpoint. And in this way, they're able to gain the credentials that are being used by that EC2 instance and gain access to the AWS account. Now there is a guard duty detection that can catch if these credentials are being used from outside of that instance. So even though it's possible to exploit, it might raise some alerts. And now we are going to be looking into the first demo. In this demo, we have a website. The website has here a field to get some URL. So if we will go ahead and we input the URL of the instance metadata, we can see that we get a reply. This means that the application internally is doing an HTTP request to whatever URL we provide. So in this case, we can append here in the URL latest, because we want to look at the latest metadata. And now we can select, you can see these are directories that are available. So we can navigate through them. We're interested in the metadata. I'm going to go for the IAM role directly. So, well, we can check other things like, for example, a instance ID. This is the instance ID of the machine, but I'm interested in the IAM credentials. So I'm going to go to the IAM directory, followed by security credentials. And now we specify that role, demo1 role. And as we can see, we get some credentials. All we need to do to exploit these credentials is copy them. I'm going to paste them here temporarily. We get an access key, a secret access key, and we will also get a session token. This is pretty standard when working with AWS roles. So I'm going to copy the token. I'm going to do this to copy the entire line and just paste it here. Now we can copy this entire snippet of code, go to a terminal, export those variables, and that will configure our AWS CLI to use those credentials. And now we'll run an STS get caller identity, which will tell us who we are authenticated as. It will let us know that we are demo1 role. So we successfully exfiltrated those credentials and assumed that role. And now we can do whatever actions this role can do. And that is all for demo number 1. Let's move on. So what are the differences between version 1 and version 2? In version 1, which was the demo that we just walked through, we see that it's just a GET request to the instance metadata IP. However, in version 2, it gets a bit more complex. The requests that we make to the instance metadata have to be authenticated with a special token. And to obtain this token, we need to do a put request with a special header stating the time to live of the token. In this case, it's set to a high number. I believe this is 6 hours. So we need to do a put request to this API token endpoint, and then we need to include that API that token in this other header, metadata token, whenever we do a GET request to get any metadata. So this makes it a bit more tricky to exploit, because now the attacker with a regular SSRF, server-side request forgery, will not be able to change the method in order to put a put request. So vulnerabilities such as a simple SSRF will not be able to exploit this instance metadata. Some vulnerabilities like XSS from PDF generators, the first time you think about it, you might think they will work, but after trying it, I don't think it can work, and I think it's due to cross-origin requests being blocked by IMDS. So the vulnerabilities that do allow this exploit are code execution or really powerful SSRFs in which you can specify what kind of method and headers you want to include. So some kind of really flexible proxy, maybe you can do this, but in general, I would say SSRFs are no longer a threat to IMDS v2. So now in the demo, we have an RCE. So I'm just going to demonstrate the RCE by running the ID command. This is running a ping to whatever is in front of the semicolon, but then when you do a semicolon, it starts another command. So it executes whatever you put here. So let's try to do a curl to http://169.254.169.254. And as we can see, there is no result. This should come back with some data. If we type v, does it give us any other data? No. Okay, so the way we're going to have to exploit this is by having first a put request. Have it typed here so I don't have to type all of this. So we're doing exactly what we saw in the slides. We're doing a put request to API token, and we're also including the header for the TTL, and this will return us a token. Now we need to copy this token to include it in the next request, which is here. So just change the token, and we can go ahead and paste this here. And in this case, what we're doing is adding the token in the metadata token header, and then accessing the instance metadata for the IAM credentials demo2 role. We would need to normally walk through these directories, but I know what the role name is, so we'll just go ahead and grab it. Now here we have some credentials. Again, just copy them and paste it here. The secret access key, copy, and finally the session token, which is normally really long. Okay, all the way up to here. Copy this part and paste it. Now we can copy this snippet back to our terminal, paste it here, and then AWS STS get caller identity in order to get what role we're logged in as. And as you can see, we are demo role 2. Cool. Back to our slides. So we're going to start talking about other other AWS services. In this case, we're going to start with ECS, which is the container service. This is a managed service by AWS, which allows us to give it a container and it will run it for us. Under the hood, ECS runs on EC2. So there are containers running in EC2 instances, and therefore the container, it can access the instance metadata of the instance. And there is also another instance metadata. In this case, it's not instance, it's called the task metadata, and this belongs to each of the tasks, which are the containers that we're running within ECS. And they have a small difference. The URL is different. Now, instead of having the 169.254.169.254 IP address, we have this other IP address, which is specified in an environment variable. And also the credentials are found in a different path, which can be found in this other environment variable. And it includes a non-predictable UID, which means that SSRFs will also not be able to get the task metadata credentials. So we should be able to get credentials from the EC2 instance, but not from the task running in that instance. In order to get credentials for the task, we only need a local file inclusion to be able to read the proc self environ file and be able to get the value of this environment variable, or we need a full remote code execution. So let's go ahead and do this demo. Here we're going to first do a local file inclusion to get the environment. And as we can see here is that environment variable that we were talking about. And we can see this is the UID that I was talking about. So let me copy this and paste it here. And now we should be able to, if I go back, paste it here, and we're basically getting the credentials from that different IP address that we were looking at in the slides. And here we have credentials for that token. So once again, we're just going to paste them into this code snippet to make it easier. And finally, our session token, which is always super long. Okay, all the way up to here. Copy this, paste it, copy the whole snippet, go to our terminal, we can paste it here, and now if we run AWS STS get caller identity, once again, we see that we are authenticated as demo3, and in this case, the name of the role is slightly different. It's ECS task, because this is part of a ECS task. Back to our slides. The next one in the agenda is CodeBuild. CodeBuild is a managed service that AWS provides to run CI/CD pipelines. These CI/CD pipelines run in containers, and under the hood, AWS is using ECS to run the containers, and therefore you can do the exploit that we just talked about with ECS task metadata from CodeBuild to exfiltrate the role that is assigned to that CodeBuild task. With EKS, which is the AWS managed Kubernetes service, the pods running within a cluster, they can access the instance metadata of the node that runs that pod. And therefore, from a pod, you should be able to get access to the role that is running in that node, because the node is an EC2 instance. This can be something difficult to block, because even though you have Kubernetes network policies, which can be used to block access to the instance metadata IP, there are some legitimate use cases for assuming the node's role from a pod in order to have IAM credentials, like have access to resources in the AWS account. However, there are better ways of doing this through IRSA, which stands for IAM role for service accounts. And also there is a new authentication strategy for AWS and EKS integration called pod identity, which is way more secure than just giving permissions to the node role and assuming that from the pods. There is a big issue with this kind of vulnerability in EKS, and that is that by default, the node's role is associated with the systems node group in Kubernetes, which has permissions to impersonate any pod in that Kubernetes cluster. And with that, you're able to steal credentials for Kubernetes service accounts running in those pods. And in most cases, in EKS, it will result in full cluster compromise, allowing an attacker that gains like an SSRF in a pod to be a Kubernetes admin, especially if the control plane of the Kubernetes cluster is public. I've linked a very interesting article here which showcases this attack, because this is too long for this talk. And finally, to sum up, we are going to look at some key points. First one is that knowing the underlying infrastructure of your target can allow you to increase drastically the impact of the vulnerabilities that you find. And maybe a report that would have a low criticality because it's a staging thing, or maybe the data that service has is not very critical. By being able to pivot inside the AWS account, you might be able to get a lot more impact out of it. Also, services that run on top of EC2, like ECS or EKS, can also access the instance metadata, so that's something to take in mind. ECS tasks have task metadata, also have EC2 instance metadata, but the task metadata can contain other roles, so it's something that we should always check for. And finally, EKS instance metadata can lead to complete cluster compromise. Thanks for listening today, and thank you, Nahamcom, for having me.